Good morning, everybody. Welcome to a rainy Wednesday morning of Chem 1105 with your host, me, Dr. White. Hi, everybody. All right, I got some announcements I want to go over. First of all, let's get the blackboard. Today, when I'm through with today's lecture, I will be sending out an email to all of you with the password for test number 2 PDF file, which you can download from the assignment area of Blackboard. Let me go into student view. Hold on one sec. If you go to assignment area, you'll now see test number 2. And here's the PDF file. You can't download it yet because you need the password, but I will send that out right after I'm finished today with today's lecture. I think I might end a little earlier so I can send out that email and you can get started if you want to. I'll notice here you have a a periodic table, instructions for submitting my tests and lab reports, and CAM scanner file to tell you how to use it. Now, as I sent out the other day an email, and I'll send out in today's, please submit this test as a single PDF file. If you don't, I reserve the right to subtract up to 50 points from your test total. I'll say that again. Please submit this test as a single PDF file. I don't want to see a bunch of JPEG or picture files. The instructions tells you if you do not have a scanner, how to take pictures with your cell phone. Actually, it would be the button over here, actually on this side, and how to convert that into a single PDF file. That's all I want to see submitted. And you will have until tomorrow, 1 p.m. to take test number 2 and upload it. And as I've mentioned, here's what test number 2 will cover. Hopefully it's done the practice point. Now here I have 25 points. I've changed my mind. It's now 50 points. In other words, you better upload a single PDF file or you're going to lose a lot of points. And next week, Monday, I will go over all the answers. I'll cut that out of the Zoom meeting, but I'll post it as a private YouTube video. That's the one with the answers for test number 2. And I'll send each of you the URL for that video. Now, also, by this Sunday, 1 p.m. or earlier, I hope a lot earlier, at that time, I'll post an announcement. I'll send out an email to you that your test number 2 score is in Blackboard. Also, before next Sunday, this Sunday, 1 p.m., I will send out individual emails that will have how many points you got for each answer, for each problem or part of a problem on test number 2. Just to remind you, underneath your name and where you have to sign it for test number 2, it will say, please use proper significant figures for all calculated answers. It will also say, please use 3 significant figures for all atomic weights. If you don't do significant figures, if you don't use 3 significant figures for atomic weights, I take off a point. For each problem, you don't do that correctly. So make sure you do that correctly. All right, any questions? All right, another very important announcement. A number of you, shame, shame, but a number of you have not been handing in some of the labs for various reasons. And what I have done is let me exit this. If you look, I sent out this morning, just before 9 o'clock, a lab amnesty program for Chem 1105. And because a number of you have not handed in all the labs, that's going to hurt your grade, really hurt your grade. I'm offering a lab amnesty program. If you do not have a score for a lab in Blackboard, meaning you never turned it in, that was already due, then you should submit that lab, or if you have more than one, those labs to Blackboard before Thursday, the 27th of April, the end of this month, at 5 p.m. in order for me to grade that lab or those labs that you will get points for. Because it is late, I will take off 1 point for each lab you submit. If you had a perfect score, normally 10, since it's late, even under the amnesty program, you'll get 9 if it was a perfect score. If it was less, I still take off a point. Now, after that time and date, I will enter a 0 for any lab that was due but was not submitted for grading for the labs we've done so far. So if you have not handed in all the labs, here's an amnesty program, so you won't lose a lot of points. A couple of you are missing 3 or 4 labs. That's 40 points. Now, if you hand it in and you take off 1 point for each of those 4 labs, you can still get 36. And 36 is a lot better than 0. Really, it's a lot better for your grade. So that's my amnesty program. All right, any questions on that? All right, in light of today's test, I thought I'd do something nice for you people. So just a quick, oh, I got to open up something. Hold on. Or don't hold on. Don't let go. All right, that's open. So now I can get started. Oh, I forgot to do one other thing. It's Dr. White Forgets to Do Things Day. All right, now I'm ready to do that. In light of today's test, I thought I'd do a couple quick things that could help you out. I have to get my stylus that was charging. All right, let's get to work. So the question is, how many moles of H2SO4, which is sulfuric acid, which I'll teach you more about later in the semester. This is sulfuric acid. It's probably one of the most widely manufactured and used chemicals in the United States, if not the world. Sulfuric acid is in your car battery and helps it work. And it's used for a lot of other important things. So let's take a look at this problem. The first thing you should do is figure out, what are you being asked to find? I'll let you try that first. I'll give you 15 seconds to figure out, what are you being asked to find? I'll make it 30 seconds. And what are you given? I'm looking at my clock up here with the seconds going. It doesn't go click, 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 or tick, 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 because I don't have any clocks like that anymore. They're all digital. All right, what are we being asked to find? How many moles of sulfuric acid, H2SO4? What are we given? 7.86 times 10 to the 45th molecules of H2SO4. Well, the only number we have to work with is this, so I will. So let's put this down. And now, what answer, unit-wise, are we trying to get to? Well, we took the time right here to say we're trying to get, and that's why I used the question mark, moles of sulfuric acid. And now, how do we proceed? Well, if there was a ratio that we could multiply this molecules of H2SO4 to get the moles of H2SO4, what would it be? Well, it's time to use your good buddy, your good friend, unit analysis. And whatever you're trying to get to goes on top of the ratio. Whatever units you're trying to get rid of go underneath the ratio. And let's write those in. And where do we get a relationship between moles of a compound, sulfuric acid, and molecules of a compound, sulfuric acid in this case? Well, in case you forgot, look at test number 2, important information. 1 mole of a compound equals Avogadro's number, that's 6.02 times 10 to the 23rd, molecules of that compound. Again, 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules of that compound. And remember, when you have one thing equal another, there are 2 ratios you can form. C equals D. C over D is 1 ratio, and D over C is another. And here, what I just showed you, 1 mole equals 6.02 times 10 to the 23rd molecules of H2SO4. And that's from that relationship, 1 mole equals Avogadro's number, I can write either this or this. In this case, it would be this ratio, moles per molecules. Now, before I don't pick up the calculator yet, I'm going to check, do my units give me the right answer? Notice you'll have molecules of sulfuric acid divided by molecules of sulfuric acid. Anything divided by itself equals the number 1, because it cancels out. This cancels out. We're left with moles of H2SO4. That's what we want. And now I can pick up my calculator, turn it on, clear it. 7.86 blue double E, 45 divided by 6.02 blue double E, 23. And my calculator gives me this number. And remember, on test number 2, it will say, please use proper significant figures for all calculated answers. So what do? Well, how many significant figures in this number? 3 significant figures. How do we know that? All non-zero numbers are significant. In this number, how many significant? Well, there are 2 non-zero, but any zero confined between 2 non-zero numbers or any zero after the decimal will be significant. So this has 3 significant figures. And when you multiply and divide, you get the same number of significant figures in your answer as the number that has the fewest significant figures that you're multiplying and dividing by. In this case, it's 3. So you have to round this number to 3 significant figures. And I'll give you 15 seconds, 3 times 5, to do that. All right, how do we do that? Keep the 1, keep the 3, keep the 5. Those are my 3 significant. Keep the 5, keep the 0. Got ahead of myself. Use the 5 to round off. Is that 4 or less or 5 or higher? And hopefully I'll pick 5 or higher. This and everything else I delete, and the number in front I increase by 1. So the correct answer would be this. Now, I do this, but you don't have to put the units down. And that would be the correct answer. How many moles? Now, remember, when you're doing a word problem, relax. I know in the past you go, word problem, relax. If you've been following along, you know first, find out what are you being asked to find, the units. Moles of H2SO4. Find out what you're given. And once you write this all down, you never have to look at this again. And then what do you have to start with? This number. What units are you trying to get to? That. If you had a ratio that you could convert molecules of sulfuric acid to moles of sulfuric acid, use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top. Whatever you're trying to get rid of goes underneath. And then where do you have a relationship between moles of a compound? That's what sulfuric acid is. And molecules of a compound? Well, in case you forgot, in days old, when I used to teach this a number of years ago, you have to memorize this. You don't. Good news, because the important information, the relationship of 1 mole of a compound is 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules of that compound. And I should mention, we call 6.02 times 10 to the 23rd Avogadro's number in honor of the great, I believe he was Italian scientist, and back then, I don't even know if they called them chemists, who really heavily advanced the concept of the mole. And that's why that number, he actually didn't come up with that. Two German scientists, chemists, and I can't remember their names either, unfortunately. All right. Let's do one more important problem. I already used number 8. Let's do something else. All right, let's look at this one. How many grams? G is grams. That's a weight. You should know G is abbreviation chemists use, Dr. White uses, and all other chemists use for grams. So how many grams of water are 3.434 times 10 squared moles of water? So I'm going to give you 20 seconds to figure out what are you being asked to find, maybe 25, I'll be nice today. What are you being asked to find, and what are you given? All right, let's take a look. What are we being asked to find? How many grams of water? I hope you all know H2O is water. And by the way, NaCl, sodium chloride, is table salt. And if you ever go out to breakfast, lunch, or dinner with a chemist or group of chemists, and unfortunately, I have to admit I've done this many times, one of us will ask, can you please pass the NaCl? NaCl? Well, pronounce this NaCl. All right. A little non-useful information, never hurts. All right, what are we given? We're given this number, 3.434 times 10 squared moles. So once we do this, we don't have to look at the word problem again. Well, there's only one number I have to work with, and that's this. Don't forget to put down your units. And what units do I want my answer to be in? Well, we took the time to figure it out. That's why I put a question mark there. We're trying to get grams of water. And now if you had a ratio that you could convert moles of water in one step to grams of water, what units would be on top and what units would be underneath that ratio? Now I'm going to let you try that first. Go ahead. What units go on top and bottom of that ratio? 20 seconds. Go. Go. That wasn't nice. And you know it's coming up. Yes, let's do it. How do we know it goes on top and bottom of that ratio unit-wise? Use your good buddy, your good friend, unit analysis. I love my whistle. I got 4 of these. The company that made it was from West Germany. That's how long ago it was made. And it's been out of business, and you can't get these quality ones anymore. I have 4 of them, and they don't leave my home ever. All right, let's use our good buddy, our good friend, unit analysis. Whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. And now I'll write those in. Grams of water and moles of water. And where do we get those numbers? Well, let's look at important information, test number 2. And where do we see on here a relationship between moles of a compound and grams means the weight of a compound? Right here. 1 mole of a compound equals the molecular weight of that compound in grams. 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of that compound is the sum of all atomic weights. The molecular weight of a compound is the sum of all atomic weights. So we now know for every 1 mole of water, that's equal to the molecular weight of water in grams. Well, how do we determine the molecular weight? MW is shorthand for molecular weight of water. Well, it's the sum of all atomic weights. There's 2 hydrogens, 1 oxygen. 2 times the atomic weight of hydrogen, 1 times the atomic weight of oxygen. Where do we find those atomic weights? From your friendly neighborhood periodic table. Hydrogen, underneath the chemical symbol, you see the number 1.008. That's the atomic weight of hydrogen. Now, on test number 2, it says, please use all atomic weights to 3 significant figures. So if we round that off, we keep the 1, keep the 0, keep the 0. Use the 8 to round off. Is that 4 or less or 5 or higher? And time's up. Hopefully you picked 5 or higher. I drop the 8 and increase the number in front by 1. That gives us 1.01, 3 significant figures. Now, if I come over to oxygen, 15.999. I'm going to let you round that off first to 3 significant figures. All right, let's do it. 3 significant figures, keep the 1, keep the 5, keep the first 9. That's my 3 significant figures. The next 9 I use to round off. Is that 4 or less or 5 or higher? And hopefully I'll pick 5 or higher. So that second 9 and the third 9, I'm going to drop. I'm going to increase the 9 after the decimal point, 0.9 by 1, which gives me 1.0. 1.0 plus 15 is 16.0. So now we can go back and we know that the atomic weight of hydrogen, the 3 significant figures, is 1.01. Oxygen, 16.0. 2 and 1 are exact numbers, so it's 2.02, 16.0. Now add these up. I get 18.02. Now, on test number 2, under your name, it says, please use proper significant figures for all calculated numbers or answers. And 18.02, we just calculated. Well, how do we use proper significant figures for an addition? You get the same number of significant figures to the right of the decimal point as the number you're adding that has the lowest significant figures to the right of the decimal point. This has 2 significant figures to the right of the decimal. This has 1, which is a smaller number. Hopefully I'll pick 1. So now I have to round this number, 18.02, to 1 significant figure to the right of the decimal. Keep the 0, that's my 1 significant figure. Round this, use the 2 to round off. That's 4 or less, so the number is 18.0, which we need up here. How we get this? 1 mole of a compound equals the molecular weight of that compound. Now, before I pick up my calculator, I'll look do my units cancel out to give me the right units. And moles of water divided by moles of water, anything divided by itself equals the number 1, which means it cancels out, and I'm left with grams of water. And now I can pick up my calculator, clear it. .432 blue double E 2 times 18.0. And my calculator gives me this number. Now, on test number 2, it says, please use proper significant figures for all calculated answers. And when you do multiplication division, you get the same number of significant figures in your answer as the number you're multiplying dividing that has the fewest significant figures. Now, all non-zero numbers are significant, so this has 4 significant figures. Zeros after decimal point are significant, so this number has 3 significant figures. Which is the lower number, 4 or 3? Hopefully you pick 3. Now you need to round 6.1812 to 3 significant figures. And I'll let you do that, and then I will. All right, let's round this off. We need 3 significant figures. Keep the 6, keep the 1, keep the 8. Those are my 3 significant figures. Use the 1 to round off. Is that 4 or less or 5 or higher? And hopefully pick 4 or less. I'll drop this and this. And since it's 4 or less, I don't change the numbers in front. So the correct answer for this is 6.18 times 10 to the 3rd grams of water. And that's how you do it. Now, I went through yesterday, so I'm not going to go through it again. The 3-step process for mass calculations. Remember, mass means when you start out going and you need to go from grams to grams. You can't do that on 1 step. You need 3 steps. Look at yesterday's video. That would be, well, let's go take a quick look. Maybe not so quick. That was yesterday's video. File name, this one right here. 2023-04-04. If you ever want to know what's in the video, click on Show More. Test number 2 information. I did the lab on periodic table and chapter 5, part 1, mole problem, part 2, which here I'm doing those problems. So hopefully you've studied, you've done the practice problems, and you should be ready for test number 2. All right, let's move on. Yesterday, I started talking about material on chapter number 6. Yep, 6. I like those special effects. Anyways, that material I'm going to go over now on chapter 6 will not be on test number 2, but it will be down the road on test number 3. So let's take a look at where we were yesterday. Now, I was talking about pressure. We're talking about gases. An important measurement of gases is pressure. Now, I'll never ask what's the formula to measure pressure, but it's force per unit area. And we use a gauge to measure it. The most important measurement of pressure of a gas is the atmospheric pressure, the air around us. I like that special effects, all around us. And we use a barometer. And atmospheric pressure, or pressures in general, are measured in units called millimeters of mercury, mm, millimeters, Hg, mercury. And the first barometer was created or invented, that's a better word, by the great Italian scientist. I don't think back then they even called him chemist, Torricelli. And in honor of his great work, 1 millimeter of mercury is also called 1 torr. They shortened his name. Now, another important measurement of atmospheric pressure is when there's no storms coming through, what's the atmospheric pressure at sea level? By definition, it's 760 millimeters of mercury, Hg, mercury. And that's the pressure at sea level. By the way, Chicagoland area is just about at sea level height or depth. That reminds me, I worked for, time out for Dr. White's story, bring back good memories. I worked for 2 Anglo-Dutch companies, which were really headquartered. Both of them, one division, the other the main headquarters, were in the Netherlands. If you've never been to the Netherlands, you should go. It's a wonderful place. The people are amazing, so wonderful. And most of them, like 99.9%, speak English. They also speak Dutch, but English, because if they go 2 hours in any direction or less, you're out of the country. And they don't speak Dutch there. But anyways, I used to work there, and I lost my train of thought. What was I talking about? See what happens when you bring back a really good memory? Oh, now I know. And most of the Netherlands is under sea level. Yes, they reclaimed the land from the sea to make most of the Netherlands. How do they do that? And this will never be on a test of mine, but I think it's cool. Does everybody see the picture? And I can check myself. Yep. You look over in the corner here, or up here in the center, or over here in the top, that's an area called Kinderdijk. Kinder is children dikes. And I've been there. I actually have some good pictures of me standing in front of some of those windmills. Beautiful sight. And what are those windmills? Those are a source of power. And one of the uses of power is they'd build a dike, and then on the side toward the land, which would be flooded after still flooded with the water, they pumped out the water using those windmills. Those windmills, a lot of them are just giant air-powered pumps. And that's how they reclaimed the land from the sea to make the country. Most of the Netherlands, or a good part of it, is under sea level. That's why I got sidetracked, which is a good sidetrack. Now, they also have windmills that mill grain too, and I've been in those. And if you notice this windmill, most Americans don't realize that, but see the cloth here on this arm? That's a sail, just like on a sail ship. It catches the wind and makes it turn. And here they had the sails down, they weren't up. But Kinderdijk, what a great memory. All right, let's get back to chemistry. So at sea level, it's defined 760 millimeters of mercury equal, since 1 millimeter mercury equals 1 torr, it also equals 760 torr. Now, because of this, and for certain things I'll teach you later this chapter, chemists also created a new unit or measuring unit for gas pressure, and that's the atmosphere. And that's abbreviated by the letters ATM. And by definition, 1 atmosphere at sea level, no storms, equals 760 millimeters of mercury. I don't have it here, but that also equals 760 torr. And that's the definition. Therefore, each one of these numbers are exact numbers, which do not play a role in determining the significant figures in a calculation. Again, 760 mmg, millimeters of mercury, 1 atm, atmospheres, and 760 torr in this relationship are exact numbers. Now, I have here know this. Now, in the past, students have to memorize this. But as I told you the first day of class, I've cut down the memorization. And for test 3, I will give you that. Now, if I look at the clock, now is a good time to take a break. I'm going to take a 5-minute break. I can get up and stretch. And I'll see you in 5 minutes. So do come back and we'll continue on. I'm back. All right. We were talking about, let me do one thing first. All right. We were talking about, okay. We were talking about pressure. And remember, 760 millimeters of mercury, mm means millimeters, Hg mercury equals 1 atmosphere, ATM means atmosphere, equals 760 torr. So there are other units which I talked about yesterday that we won't use in this class, but we use in our daily life. Inches of mercury are found in weather forecasts, and pounds per square inch, PSI, are used for things like your car tires. All right, let's do some practice time. And let's take a look at this. How many torr? And I'm going to, instead of this, I'm going to do it on the whiteboard so I won't have to jump. All right. All right, now let's take a look at this. Question is, how many torr is 851 millimeters of mercury? mmHg is millimeters of mercury. Now, for test number 3, you will have the following. If I write it correctly, that's this you'll be given in test number 3, important information. So how do we proceed? Well, do what I've always taught you. What are you being asked to find? Torr. What are you given? And now the only thing we have is this number to start with. So I will. What units do I want my answer in? Well, we figured that out. Torr. And guess what? It's time to use your good buddy, your good friend, unit analysis. If there was a ratio I could convert millimeters of mercury to torr, what would that be? Whatever I'm trying to get to goes on top of that ratio. Whatever I'm trying to get rid of goes underneath. And now I'll write that in. And now where do I get those numbers? Well, right here. 760 torr equals 760 millimeters of mercury. And before I pick up my calculator for this one, you really don't need a calculator, but if you did, check your units. Notice you have millimeters of mercury divided by millimeters of mercury. Anything divided by itself equals the number 1. This cancels out. I'm left with torr. And remember, each one of these numbers in this relationship 760 millimeters of mercury equals 760 torr equal 1 atmosphere. ATM is short for atmosphere. These are all exact numbers. And exact numbers play no role in determining significant figures. This has 3 significant figures. Therefore, my answer, which if you do the math, is this: 3 significant figures. All right, let's you try one. Oops. And the question is, how many millimeters of mercury, mmg, hg is millimeters of mercury, 6.6751 torr. And since you can't see it, I will remind you. This 760 millimeters of mercury equals 760. Remember, this is how I write the number 7, the German way, which I think is cool. I learned from my high school teacher in German. High school teacher was from Germany, Herr Brink. I still remember him. What a great guy. But anyways, 760 torr equal 1 atmosphere. Now let's do this stepwise. I'm going to let you do it. What are you being asked to find? What are you given? Your turn. All right, what are you being asked to find? I like putting a question mark to let me know that's what we're trying to find. Millimeters of mercury. What are you given? This number, 6.6751 torr. Well, this is the only number we have to work with. And if there were some ratio, I could convert torr to what answer do we want here, unit-wise. Your turn. And that's millimeters of mercury, mmg. Why do we know that? Because we figured it out. Now, what goes on top and bottom of that ratio? Hint, use your good buddy, your good friend. I'll let you try first and I'll do it. What units go on top and bottom of that ratio? I'll give you another 20 seconds. See how nice I am today? Especially with all the holidays coming up next couple days for different religions. In case I forget, let me take a stop. I'll try and remember to do it at the end of this video, but I'd like to wish everybody who's celebrating tonight, Wednesday, April 5th, a happy Passover. Hopefully you're going to a really good Seder. I'd like to wish everybody who's celebrating Easter this Sunday a happy Easter. I hope you get all the eggs and chocolate bunnies you want. And for those of you who are celebrating Ramadan now, I hope you have a happy Ramadan or having one. And if you're not celebrating Passover, Ramadan, or Easter, I hope you have a happy rest of the week and weekend. I think I covered all the bases. So Question is, what goes on top of this ratio? What goes underneath unit-wise? And how do you know? Use your good buddy, your good friend, unit analysis. Whatever we're trying to get to goes on top. Whatever we're trying to get rid of unit-wise goes underneath. And where do we get those numbers? From right here. 760 millimeters of mercury equals 760 torr, and that's the relationship. Remember, when you have two things equal to each other, in this case, 760 millimeters of mercury equals 760 torr, you can have two ratios. Oops, that's not equal, it should be and. And here, that's how we got these numbers. And now, before I pick up my calculator, this one you really don't, but if you did, torr divided by torr, anything divided by itself equals the number 1, meaning cancels out, and I'm left with millimeters of mercury. Now, this is 1, 2, 3, 4, 5 significant figures. These are exact numbers. And my answer is this, 5 significant figures. All right, let's have some more fun with this. And let's do the following. All right, let's take a look at this. How many atmospheres are 4.312 times 10 squared torr? So let's do, I'm going to let you do part of it on your own. What are you being asked to find? What are you given? Your turn. And the answer is you're trying to find how many ATM. ATM means atmospheres. It's a unit of pressure. And you're given this number. Well, this is the only number we have to work with, so I will. So I have this number, 4.312 times 10 squared torr. Now, if I had a ratio, I could convert this to what units do I want my answer to be in? Yep, you're right. We figured it out. Atmospheres. And now it's time to use my good buddy, my good friend, unit analysis. And it has been for many decades. Oh, I shouldn't have said that, but it's true. And whatever we're trying to get to, the units go on top of the ratio. Whatever we're going to get rid of, the units have to get rid on the bottom of the ratio. And now write those in. Now, in important information, test number 3, you will be given this. And that is 760 millimeters of mercury equals 760 torr equal 1 atmosphere. So where do we get the numbers here? For every 1 atmosphere, there's 760 millimeters of mercury. We don't need that, but we do need the 760 torr. Now, I'm going to pick up my before I pick up my calculator, bad Dr. White. I'm going to check that my units cancel out. Notice torr divided by torr, anything divided by itself equals the number 1, cancels out. And they do, and I'm left with ATM, atmospheres. Yay! So now I can pick up my calculator, clear it. .312 blue double E 2 divided by 760. And my calculator gives me this number. I better write it over here because I got a lot to write. This. And how do we know what should be the answer? On test 3, like test 2, like test 1, it will say underneath your name, please use proper significant figures for all calculated answers. And for multiplication division, you get the same number of significant figures after the decimal, or same, bleh, got confused there. I'm thinking ahead of myself. That's dangerous. All right, you get the same number of significant figures in your answer as the number you're multiplying and dividing that has the fewest significant figures. Well, let's take a look at these numbers. This has all non-zero numbers are significant. 1, 2, 3, 4. 4 significant figures. 1 is an exact number. And 760 is an exact number. So my answer should have 4 significant figures. Keep the 5, keep the 6, keep the 7, keep the 3. Use the 6 to round off. Is that 4 or less, or 5 or higher? And 5 or higher. Drop all these. Increase this by 1. And the correct answer is 5.674 times 10 to the minus 1 atmospheres. Remember, ATM is atmospheres. Oh, let's do another one. I'm going to let you have fun. Dr. White shares. And the question is, how many millimeters of mercury is 3.12 times 10 to the 5th ATM? I'm going to let you first try and figure out what are you being asked to find, what are you given. While you're doing that, I'm going to write something important we'll need. Well, you'll need, I already know this by heart. All right, if we have this and we look at this, what are we being asked to find? How many millimeters of mercury? Now, I could have written it, how many millimeters of mercury oxygen gas is 3.21 times 10 to the 5th atmospheres of oxygen gas, or just O2. O2 is a gas. But I'm keeping it simple. What are we given? This. So how do we proceed? I'm going to help you out, and then you're going to have to do some work too. This is what we're starting with. What units do I want my answer in? Your turn. And the answer is, well, we figured it out right there. We want our answer to be in millimeters of mercury. Now, if there were a ratio that I could use to convert atmospheres to millimeters of mercury, what units would I put on top and bottom of that ratio? Just the units. Your turn. Use your good buddy, your good friend. All right, let's use our good buddy, our good friend, unit analysis. Whatever we're trying to get to, units go on top of the ratio. Whatever we're trying to get rid of, go underneath. And now write that down. Oops, yep, not oops, I had it right. For a second, I thought I made a mistake. Then I looked at my units. Now, where do we get those numbers that go a ratio of millimeters of mercury? Hold on. I don't know why I always use hold on. Don't let go. Hold, wait a second. Actually, it's more than a second. That looks better. Where do we get a relationship between millimeters of mercury, mmHg, and atmospheres, ATM? Right here. 760 millimeters of mercury equal 1 atmosphere. 760 millimeters of mercury equal 1 atmosphere. Remember, all these in this definition, 760 millimeters of mercury, 762 equal 1 atmosphere, are exact numbers. Now, before I pick up my calculator, so I didn't yet, I'm going to check do my units cancel out. That's part of unit analysis. Notice I have ATM, atmospheres divided by atmospheres. Anything divided by itself equals number 1. And I'm left with millimeters of mercury. Yay, that's what I want. And now I can pick up my calculator, clear it, 3.21, second key, double E, 5 times 760 equal, and my calculator gives me this number. .4399 times 10 to the 8th. Now, and test 3, like test 2, will say, please use proper significant figures for all calculated answers. This is 3 significant figures. These are exact numbers. And when you're doing a calculation, you get the same number of significant figures when it's a multiplication division in your answer as the numbers you're multiplying dividing that has the fewest significant figures. Well, if we look here, these are exact numbers, so I can't use those, or I don't use those. And the only number I use to determine significant figures is 3. I'm going to let you round this off to 3 significant figures. All right. How do we round this off to 3 significant figures? Keep the 2, keep the 4, keep the 3. Use this number to round off. And is that 4 or less or 5 or higher? And hopefully I'll pick 5 or higher. So I'm going to drop that, increase this by 1. And this is my answer, 2.44 times 10 to the 8th millimeters of mercury. And that's how you do pressure. And we've done our pressure practice time. I've done different numbers than here, but same. Now, this would be a good time for me to say I'm done for today, because in a little while, I'll be sending out the password for the PDF file for test number 2 that you take from the assignment area of Blackboard. Remember, please upload test number 2 as a single PDF file. I'm going to take off a lot of points. I don't want to see multiple JPEG or other picture files. That makes my life too difficult, and trust me, it's difficult enough as it is. I don't need any more extra work. So with that, I'll remember now, which I did earlier, for those of you who are celebrating Passover, I hope you have a great Seder tonight. If you're going to Seder, I hope you have a happy Passover. For those of you who are celebrating Ramadan now, I hope you're having a happy Ramadan. Hopefully that's the right greeting for that. And for those of you who are celebrating Easter this Sunday, I hope you have a happy Easter. And with that, I'm going to say, gang gesund, goodbye. Stole that from Granny and the Beverly Hillbillies. Bye now. Have a happy holiday or just the rest of the week. Bye. Wow, it's still working. Bye now.